Thank you. Awesome. Hello, everybody. Thank you so much for coming. I'm Jo Franchetti, and as mentioned, I am a developer advocate at Spotify. I work on the Spotify developer portal. You can get me at This Is Jo Frank on all of the socials, whichever socials we are using these days. And I'd like to talk to you about the importance of developer experience. So let's start with a story to illustrate what some of you may have experienced before. So you're a software developer and you've been asked to integrate a new developer tool, and we're going to call it Codemajig. Someone at your work has told you that Codemajig has been recommended for its advanced features and its time-saving capabilities, and you're excited about the potential that it offers. So you embark upon the journey of learning what Codemajig can do and how you can onboard with it. And you start with the obvious. You use your favorite search engine to find online tutorials, to find their documentation, to try and understand the basic concepts and functionalities of Codemajig. But you quickly realize that the available learning resources are scarce and they're quite poorly structured. The official documentation is not only incomplete, but it's also outdated. It lacks clear examples, it lacks practical use cases, and you have found some tutorials, but they're either overly simplified or they're way overcomplicated, and they leave you feeling confused and frustrated. But you're determined to overcome this initial setback, so you reach out to the Codemajig community to ask for assistance, and you join their online forum, you join their Discord, and you hope to find guidance from some experienced users who've used Codemajig before. But the community turns out to be kind of unresponsive and unwelcoming to newcomers, and your questions just go unanswered for weeks. But you're a consummate professional, so you decide, you know what, I don't need the community, I don't need the documentation, I'm gonna just try it myself. So you decide to experiment with Codemajig, and you start by working on a small project. But you quickly discover that Codemajig has quite a steep learning curve. Its code base is complex, it lacks structure, and it's challenging to navigate. Codemajig lacks proper error handling, there's no test coverage, you're getting cryptic error messages that don't help at all with troubleshooting. You find numerous bugs and inconsistencies in the tool, and you try to report these bugs to their team, and the team just don't respond. They never resolve the issues that you raise. Weeks turn into months, your enthusiasm wanes, and you begin to question why anybody told you to use Codemajig in the first place. Their lack of learning resources, their unhelpful community, their poor user experience, their lack of support, their technical issues just make it impossible to actually use this tool. Ultimately, you and your team decide to abandon Codemajig completely in favor of another tool that offers better documentation, a supportive community, and a shallower learning curve. By Codemajig, you have lost this customer because of your bad developer experience. And I'm sure many of you have had a similar onboarding experience. This first time you use a new tool or a framework or a language is absolutely essential for your development journey and deciding whether or not you're going to continue to use this product. And we want people to use our products. And so we need to be able to sway developers to perceive the quality of our code within our organization as high quality. And developer experience, or DevX as it's often called, describes the journey that a developer is going to take when they're onboarding with your tool and when they're using your code. It's the lived experience of all of us as developers and the points of friction that we encounter as we try and use tools in our everyday work. And developer experience isn't just at the getting started phase, it's all the way through. So it's building, it's testing, it's debugging, and it's releasing products with your code. And as developers, as people who work in tech, as people who are building tools, even if you do manage to make the sale and you get somebody onboarded with the product that you're building, you need a pleasant developer experience to keep them. Otherwise, you are going to lose them the moment that they find a tool that looks better than you're offering. Poor developer experience is going to cost you money, it's going to ruin your customer base and damage your reputation. And a common misconception is that DevX is only affected by the tools and the products themselves, but research shows that there's actually a huge amount of human factors involved, such as having clear goals, feeling psychologically safe, feeling like you're part of a team, or that your project can have an impact on your well-being. So improving DX increases not only the productivity of the developers that are using, but also their satisfaction, their engagement, and it can improve employee retention. So let's take a deeper dive into things that can affect developer experience. So there was a great white paper that was released very recently by the Association for Computing Machinery on developer productivity, and I've linked that down here. I will share the slides out at the end on the socials. It breaks developer experience up into 3 segments. So we've got cognitive load, we've got flow state, and we've got feedback loops. And when we consider all of these 3 together, that's the full range of friction types that you will experience as you work. So let's take a brief look at each of these. I'm sure we are all aware software development can be difficult. It's complex, it's complicated, there are always new tools, new languages, new methodologies to learn, and writing and reading and learning code all contribute to a workload in your brain. This is the cognitive load. And cognitive load refers to how much information you need in order to complete a task. And alongside not only the how much brain power you need to complete a task, what other stuff is going on in your head at the same time, and how much effort it is going to take to not only understand that knowledge, but to retain it, to actually learn it, to keep that new knowledge in your head. And psychologists often refer to this as something called working memory, which is how much capacity your brain has to hold information. And it works actually very similar to how RAM in your computer works. So we have this certain amount of fast access storage available to us, which we fill up as we're doing tasks. And when that capacity is full, we have to stop doing one task in order to be able to successfully do another task. Otherwise, we find ourselves making mistakes. If you ever tried to do too many things at once and then miss something, drop something, forgotten something, it's because your working memory was full. And cognitive load will increase for your developer if they're working on a difficult or a complex task, or if they're trying to learn something new. And it can also be increased by extraneous information being presented while they're trying to concentrate, trying to multitask, working in a noisy environment, or working somewhere with a lot of visual noise. Things like poor documentation, too much instruction, too little instruction, badly designed tasks or confusing tasks can all increase your cognitive load. And if you're feeling bored, or you're feeling anxious, or you're feeling tired, it can decrease the amount of working memory that you have available, thus increasing your cognitive load. And when cognitive load is high, developers need to put more effort in order to complete a goal. They will likely make more mistakes, and they will have just less innovation in their work. So to improve developer experience, teams and organizations should aim to reduce cognitive load as much as possible by finding ways to eliminate the hurdles that increase cognitive load. So we should be creating well-organized code bases. We should be writing good, thorough documentation. We should be making sure that if we're helping somebody to onboard, we are setting well-defined tasks and goals that allow them to feel a sense of achievement, to give a clear objective so that they know what they're working towards. We should be, as much as possible, reducing the amount of context switching that they need to do. And if you have a dedicated DevX team, they should be providing easy-to-use, self-service tools that help developers to streamline the steps that are required for them to onboard, start using the tool, and be successful with it. And this isn't only about building external tools for external developers. This covers the developer experience of working with your own code bases that you're writing as well. Presenting information in different styles and methods can also help by making learning accessible to people who learn in different ways. I personally prefer to learn by doing, so I love demos and tutorials. Some people like to learn by watching videos, some people prefer to learn by reading. So give a whole load of different ways of displaying that information. Allow developers to use tools that will aid their own cognition. Because when cognitive load is well managed, developers will find it much easier to be efficient, effective, to be productive, and it allows for this thing called flow state to happen. And I'm sure you've all heard people talk about like, oh, I was really in the zone today, or oh, my flow was interrupted because I had to have a meeting. And this idea of being in the zone is what we call flow state. And flow state is a mental disposition in which a person becomes fully immersed in the activity that they're trying to do. And it's an enjoyable, it's an energizing feeling. You feel like you're being more creative, more innovative, you're motivated, you're highly efficient. You feel like an enhanced individual when you're in flow state. And it can make learning easier, it can make us more productive, it can even make repetitive tasks actually feel quite gratifying when we're in a flow state, because we're like, done, 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 yeah. And this feeling of enjoyment can lead to developers performing better and producing higher quality products and just being more innovative. So it stands to reason that we want to create an environment where we can produce optimal conditions for flow state. So how do we do this? Firstly, we need to make sure that the skill level and the challenge level that is being presented are well balanced. So if we're setting a task for a developer to do, it needs to present enough challenge that their mind is interested, that they're engaged in their learning, but they're not confused or frustrated. Too much challenge can leave you feeling helpless or foolish. And on the other end, if it's too easy, it can make you feel belittled, bored, make you feel like you're being babied. I remember once my dad complained that his computer was broken. And I said to him, like, why don't you just Google the problem? And he said to me, if I were to spend 2 hours, for example, trying to search for a fix for this, I have no certainty that at the end of those 2 hours, I will have a fix or even understand what I've read. But I know that if you spend 2 hours looking at a fix, at the end of it, you're going to come out with a fixed computer. His skill level wasn't up to the challenge of working out what on earth it was that was wrong with his computer, and he found it frustrating. He just gave up before he even tried. And when we're building experiences for developers, we need to consider their skill levels and how we cater for them when we're setting tasks. We want to create confidence in the developer that even if the task is quite complex, they're going to be able to solve it and have an achievement at the end. And getting this level of balance of challenge and skill allows the developer to feel like they're in control of their progress, that, you know, they're the one who is working through getting these outcomes and these achievements. We want to make sure that we are clearly defining tasks, that we're setting achievable goals, and we're helping them feel like they're moving through something. Completing tasks brings a great sense of achievement and reward, and it motivates the developer to strive to learn the next thing or do the next piece of work. And it keeps them in the flow state, reducing their chance of boredom. Conversely, interruptions, distractions, delays all hinder flow state. So anytime a developer struggles to find the information that they need to complete a task, or if they have too many tasks to juggle, they're switching between windows, they can be pushed right out of flow state because the visual information is too much, the cognitive load of trying to find information is too much. It's like shoving a hurdle out in front of a sprinter, and it doesn't even have to be a full hurdle. Sometimes it can just be a tiny little brick, and it's enough to throw somebody off. And then once they're thrown, it takes such a larger amount of energy for them to pick themselves back up and start sprinting again. And switching between tasks or getting lost or frustrated or distracted while searching for information reduces focus and reduces that stimulation at the flow state. Not only that, it can increase anxiety and unpleasant feelings in the developer. Have you ever found yourself doing something like checking your email when you're tired or frustrated with a thing that you can't work out because you don't want to face the mental hurdle that you know it's going to take in order to take that first step to start sprinting? Flow state absolutely depends on developers having the autonomy and the opportunities to work on fulfilling challenges. And the best way to find out whether or not you've got the balance correct between the skill and the challenge is to get feedback from developers. Which brings us nicely on to feedback loops. And it feels obvious, but sustaining a meaningful feedback loop between the developer that is using your product and you who are writing your products is central to developer experience. How can we possibly know that we're doing a good job if we're not speaking to the people who are using our products? And feedback allows us to spot mistakes, to learn, to improve, but it also fosters a feeling of visibility and engagement and recognition of performance. So if you're looking to improve your developer experience, you should be aiming to shorten your feedback loops as much as possible. It's imperative that you make giving feedback about your product as easy as it possibly is so that you don't block developers from telling you what they love and what they hate. You should, of course, also, when you get that feedback, action it in a timely manner. If you're just collecting feedback and doing nothing about it, they're going to stop giving you feedback. You need to let them know that you appreciate the feedback that they're giving. And doing so will allow you to easily spot where developers are struggling, where you've accidentally just thrown that brick out onto the sprinting track, where you've knocked them out of the flow state, and it'll ultimately lead to you building more beloved products and processes. Similarly, we should be looking to provide feedback to developers as they're using our products. So we should have good test coverage that allows them to know when they're doing well or when something is broken. We should enable continuous integration so that they can run their tests while they're working and get feedback without having to, recompile. We can offer steps to complete in a tutorial with a clear indication that they're working through to a finished product at the end with a success. Providing slow to no feedback can leave developers in the dark, it can interrupt them mid-process, and it can lead to an increased cognitive load. And I could really give an entire talk on feedback itself. There's so many things that we can do with feedback and to improve feedback. There's an excellent article by Tim Cochran, who is the technical director of ThoughtWorks, in which he talks about feedback loops and how to implement and measure them. It is linked at the bottom of this slide. Again, I will share the slides out at the end. So that was a general introduction to developer experience, and you can, of course, interpret these for your own products and your own tools. But I'd also like to give some practical takeaways and examples that I think can make a real difference to developer experience. So let's start with the basics first. Let's talk about our code bases. There are some standard hygiene practices that might seem really obvious, and you might be like, Joe, why are you telling me this? Well, I'm going to just write them out because I've seen some stuff out there in the wild. So let's talk about what makes a good code base. A good code base follows the default language convention of the language that you are working in at the time. Anything that deviates from these standards, however well-intentioned, however clever you think that you're being, is going to cause more cognitive load on the developer. Every change that you make to these standards is going to raise the barrier of entry to the developer who's trying to understand your code base. Also remember, every single tool that you add in, every dependency that you add into your project raises that bar again. It's another thing that they need to understand in order to successfully use your product. You're just shoving more bricks out on the track. You can reduce time spent onboarding by making use of things like containers and code spaces. Containers are lightweight packages which contain all of your application code together with its dependencies, and they create a full developer environment. So the developer who's using your code has a minimal setup. No more need for complicated dependency installation, fears about platform compatibility. GitHub offers code spaces that run your containers in a browser. Like, this could not be easier at the moment. And VS Code has a containers extension which allows you to use a container as your full developer environment. You know, we can be really making it easy for developers to be using our tools. And if you can't use a dev container, you should at least be avoiding global dependencies. So you want to ensure that your project can be easily reproduced by other developers. This is going to help maintain the integrity and the stability of your project across different setups. I'm a Windows user. Sorry, microphone. I'm a Windows user and I fall foul of this all the time. The majority of developers are on Macs. They make lovely setups for their Macs, and then I come along and it doesn't work. If the external dependencies can't be avoided, you can script them. So in the script section of your package.json file, you can define custom scripts that can be executed with npm or yarn, and they will install the global dependencies for you. But again, remember, the commands can differ between Windows and Mac, so make sure you're supporting them both. Your README file plays an absolutely crucial role in your repository. It serves as the initial point of contact with the developers that are using your products. It's your introduction to yourself. It's their introduction to you as the code writer. That's what I'm trying to say. And it helps users to quickly understand what your project's about, why they might need it, whether or not it does what they want. And a well-crafted README is going to enhance the accessibility and the usability of your product. So you really need to be investing time in creating a comprehensive and informative README that will absolutely communicate the value of your project and foster engagement with the developer community. Like, don't forget to tell them how they can get in contact with you. Personally, when I look at a README, these are the things that I want to see. So first up, if the README is long, I really appreciate a table of contents with links to sections. There are generators online if you don't want to write Markdown, which will make your contents for you. There's a VS Code extension that will do this too. You can then start the README with a brief introduction to your project. What's its purpose? What are the goals? What are the features? Then I want to know, how do I actually use this project? So what do I need to run it? What version of Node do I need, for example? How do I build it? How do I run it? Make me some nice npm or yarn commands and provide them to me as code snippets directly in the README. Really hold my hand through this. Like, give me a usage guide, provide me instructions on how to use your project, and explain the main functionalities within your code base. And include code samples. We love code samples. Include usage scenarios. Let me know if your project requires any kind of configuration. Give me an example of what that configuration might look like and how I can configure and customize the project. Specify exact configuration files or variables that need to be set. Give examples with placeholders in. Let me know any constraints, if there are any particular gotchas, any design decisions that you've made that need to be called out. Don't leave me guessing as to why it acts the way that it does. And there are a whole bunch of other things that you can also add to your README, or you can use as separate Markdown files. So guidelines for contribution, both how you'd like contributions and how users can do things like run tests, submit bug reports, how they can propose enhancements, specify your required coding styles, linting rules, testing frameworks, anything that you want your contributors to know. And also provide contact details for how they can get in touch with your team if they need to, be it Slack, Discord, email. And encourage users to reach out with questions, encourage them to ask for help, to give bug reports, or ask how they can get involved. Make sure that you include a code of conduct explaining what behavior you expect from your community and how you're going to handle violations. Clearly state the license under which your project is being distributed and any restrictions of that license. A well-written README really just massively improves the clarity, the usability, the overall quality of your project. It's really something that you cannot half-ass. And good technical writing can make a huge difference to your README and your other documentation, be it a blog post or a wiki or a portal. And technical writing and developer education it's a whole skill in itself. You're basically taking what is a very complex idea and making it accessible and adjustable. And an important component of good technical writing is ensuring that you know who your audience is, what their skill level is, what they want out of your writing, just who's reading this. So consider what level they might be at in the company that they're at. What's their technical expertise? What's their knowledge level? What's their role? What's their responsibility? Are they beginners, intermediate? Are they experts? And once you've identified who your audience is, create a persona for them and then assign this fictional person a kind of backstory as to why have they found your product? Why are they reading this README? And then you can make sure when you're writing it, you're writing with them in mind. Make sure that you're using simple, direct language to convey your message. Keep a consistent tone of voice, a consistent point of view, use consistent tenses, use consistent nouns. Write low complexity sentences, keep vocabulary low complexity as well, keep your paragraph short, give frequent examples, focus on readability and accessibility, make sure you use headings, write descriptive link text. Links need to make sense on their own, not just as part of a sentence. And of course, give any images that you have descriptive alt text. Make sure that you're using inclusive language. Think about the ability-specific language that you're using. So instead of read, try see, or instead of instead of see, try read. Instead of have a look at this, try check this out. And don't refer to things as crazy or dumb. Try instead wild or baffling. And obviously, hopefully I don't need to say this here at React Girls, but there's no need for gendered language in your writing. You can use neutral pronouns and swap out words like man hours or manning for work hours or staffing. And avoid using idioms or slang as much as possible, because these will absolutely confuse folks whose first language is not the language that you're writing in. And avoid as much as you can saying that a process is simple or easy, because this can make folks who are new to the subject feel like they're being belittled. You've told me this process is easy and I'm finding it confusing. Maybe I don't belong here. Many of us have really short attention spans these days. I know I do. Big chunks of text, I see it and my eyes kind of slip off it like it's Teflon. So try and make sure you're breaking up big chunks of text with some nice images, some visuals to illustrate the points that you're making. It also really helps with folks who just don't learn by reading. If you've got visuals, diagrams, that kind of thing, it really helps. And finally, consider, as I mentioned earlier, different learning styles. So maybe you could also include some video or some audio. The final thing that I want to talk about today is the code itself. And these are just a few things that I think can make a massive difference to the developer experience of the code that you're writing. Because we spend the majority of our time with code reading it rather than writing it. And I'm sure we've all seen a lot of illegible code bases. When we're writing code that others are going to read, it's really important that we code clearly and that we code with intention. Because you're very likely not going to get a chance to actually speak face-to-face with the developer that's using your code. So they're not going to know what you were thinking when you were writing it. The code has to speak for itself. Your code should be unsurprising to your reader, it should lower the cognitive load as much as possible, and it should allow them to stay in a flow state as they are working through it. So, functions without side effects. Yes. Functions that do one thing and one thing only. Yes. Pure functions are easier to read. They are solely dependent on themselves. They won't affect external states, meaning readers have less head compute. They don't need to keep as many things in their head. Functions with fewer arguments are generally easier to comprehend. It's just easier to read. Again, you're making your reader keep less things in their head. If you can, refactor your functions to make them smaller, reduce the number of arguments. Promises are more readable and more intuitive than nested callbacks. They make it easier to see the linear flow of instructions. They end up with more concise code blocks. They help developers to understand the flow of the asynchronous operations. And this, of course, is going to reduce cognitive load. We've all seen the promise callback triangle of doom where you're okay, so this, and then that, oh God, I've forgotten what was happening at the top. Let's try and use promises. Return early and often. So placing return statements early on in your functions and methods allows you to communicate more clearly the conditions under which the function should exit. So this reduces the need again for excessive nesting, improves the overall clarity of your code. If I can read through and then go, okay, I've got to this point and I've returned, I don't even need to read the rest. Cool. Minimizes the time that I'm spending reading your code, minimizes the need for the developer to, again, hold multiple things in their mind simultaneously. Avoid nested ifs, again, another pyramid of shame. If the nesting level increases, the code becomes more difficult to read. It becomes less legible. It's harder to follow the logic that is happening and the intentions behind the conditions of that logic. The pyramid of shame can lead to bugs, it can lead to maintenance issues, and of course, again, it's going to increase cognitive load. Make sure that you're using descriptive language in your naming rather than abbreviations. Longer function names actually make it clearer what the function is doing and can make your code self-commenting. I don't need a comment if you tell me that your function totals the cost and adds tax. Brilliant. The goal of writing clear code is that when you read it, you can understand what the code is doing. You might be tempted to write comments. The problem with comments is that comments are either lies now or they're lies in the future. And I understand that sometimes you've had to commit some kind of cardinal sin in your code and you've put a little comment in there to explain why that's happened with a to-do fix at some point. And sure, that doesn't go amiss, but comments should tell you why the code is doing what it does, not what the code is doing. And I'm going to make a lot of Vim users very angry now. I love long lines. Long lines of code are a tool that we can use to make blocks of code more readable. And I can hear you all gasping 80-character linting. But let's take a look at an actual example. So hopefully you can sort of see the shape of this, even if you can't see the code. So this is from an SDK that I wrote recently for the Spotify web API. And this is an endpoint that returns artist data. And I think this is well-written code, judging by the tips that I outlined in the previous slide. The classes and the functions are all nicely named. The functions do only one thing. There is a little comment in there which explains an anomaly that a future developer might come across. And yes, the albums function has a lot of parameters. It unfortunately has a lot of different options, but by putting these parameters all into one line, so I don't know if you can see this here, we have albums, lot of parameters here, but we've put them all in one line rather than dropping them all onto different lines. And the reason why we do this is I'm kind of saying, okay, reader, there's a lot of parameters here. They don't really matter. You don't need to know anything about them right now. Just skip that, go into the function, see what it's actually doing. Then you can go back and see if you need those parameters. Vertical spacing means something. It's lending an importance to the information that you're dropping onto a new line. You're saying, developer, you need to read and process this new line. And if we're dropping, all our parameters onto a new line, I need to suddenly understand what ID string is, what included groups are, what market is, what limit is, what the limit is, what the offset is. Like, I don't need to know all those things in order to understand what the albums function is doing. I don't need to know them yet anyway. New lines lend importance and significance. A line break, to me, suggests a new section of code. So be it a function or a logical block, a new line helps with cognition. Our brains can understand that we have separate bits of code that are doing separate things. So I'm not saying don't use new lines, like I love new lines. Like, it makes it obvious. Where have I got a nice example here? This is too short. Oh, here we go. So, I've got my if statement here. I've got a new line here before I start making some more variables because it's a different chunk of code. It's doing something new. So now let's run my beautiful legible code through a linter and see what it does to it. There we go. When I run this through a linter that is set to 80 characters, I am potentially lending significance to lines of code that are not necessary to comprehend on an initial read-through. And I don't know about you, so these two pieces of code are exactly the same. If I look at the first one and I look at the second one brings me out in a cold sweat, to be honest. If I'm sitting down to read this for the first time, it feels like there's so much more to comprehend, even just looking at the shape of it. To me, things like this up here, where we've got all our import types, like, I don't care what's being imported here. Why are you making me read all this? Put it all on one line. It kind of feels to me like hitting return in the middle of a sentence. Like, it just doesn't make intentional sense. All of a sudden I need to know, like, what have we got? Artists, market, playlists, like, what is this? It's detailed information that I don't need just yet. It's not relevant to me until I decide which of the functions in here I actually want to use. In the original formatting, the actual important information that we need to care about is on line 5, whereas in this new formatting, it's all the way down here. Like, we're just adding a huge amount of cognitive load onto our developers who are trying to read this for the first time. White space has been removed, so all of that nice new line that I put in, that's gone. What have we got? What else have we got in here? We're declaring functions on a class. These are separate concepts here. So here we've got our class, we're declaring functions on it. I put in a new line, it's been removed. Again, we're sort of squishing blocks together that maybe should be considered separate. The optional parameters that were deliberately on one line have all been moved further down the screen. Suddenly the shape of the function has changed as well. And so now we've got this, we know what a function looks like, right? We've got keyword, name, parenthesis, curly bracket. The shape of it has changed and suddenly it's not quite so obvious that albums is even like, curly bracket, parenthesis, hate it. And to add insult to injury, the top tracks return there has been spread over 3 lines. So I don't know if you can see that. Our return here, spread over 3, why? just so we could waste an entire line on a parenthesis and a semicolon. Something that had more meaning on the end of the line to which it was connected. All this extra cognitive load that we're adding, we have managed to save ourselves 3 kilobytes. So I'm sure the developer will be very happy that we provided them with this second option. So I'm really sorry, Vim users, ESLint default settings users. This just isn't better, in my humble opinion. This isn't 1996. We have widescreen monitors these days. Let's consider the legibility of our code. Let's consider the intentions that we had when we were writing our code, when we were putting it together, what we were hoping our readers would get out of this. And I guess what I'm trying to say is that my name is Jo Franchetti and I love long lines. Thank you very much.